Yeah, hi all. Today we'll discuss problem D of Codeforces around 831. So what the problem states is you have given a matrix of cross n, size n cross m, and there are numbers in the first cell initially, and those are one after the other, one on the other. So it's like it's in the form of stack. You need to bring all the numbers from the first cell to the final cell in such a way that you can just move suppose that, you can just move one number from current cell to another cell which is adjacent to it. So you can move in the form of left or right or yeah, top or down. So that's the thing, and you can just to move the to remove the to remove the first number to remove a number from the first cell, you can only remove the uppermost number. So if you want to remove two, you should remove first one, and then you are allowed to remove three. Okay. Yeah. And also in the final cell, the number should be in such a way that they are in the ascending order as seen from the uppermost view, like top view. So this come like after, like if we think a bit that what we can think is first K should land here, then K minus 1 should land here. And okay, I didn't tell about K. So the numbers are the permutation of size K, in the sense the numbers consist of all the numbers are distinct and are in the range 1 to K inclusive. Yeah, so that's the problem. Yeah, so you need to bring it like this. Yeah, you need to make it possible so that it's in the order of ascending order if we see from the top view. So how can we do this? Dimensions are n and m, and so what do you think is you need to remove, like first you need to find the biggest number in the stack, and then you need to bring it here. So to remove the biggest number, you need to remove all the numbers above the that number in the stack. So suppose this is the first example. So it is 6. So you need to remove 3, and then you can remove 6, and then you can place it in the final cell here, and then then you need 5. So you need to remove all, like, okay, after the 6 you removed like this, because 3 will be also removed. So 3 one second. So 3 will be removed, so you will be left with this in the stack is in the form, this is the topmost of the stack, just imagine like that. So you need to get 5, you need to remove all this thing, and you need to store it somewhere um so that you can bring 5, like you can get a chance so that 5 will appear in the top of the stack. So yeah, where you can store, you can ignore this. Yeah, you can ignore the green lines now. You can store it somewhere here. You can store it somewhere here because all the cells are initially empty. You can store it somewhere here, and then after you store, suppose first we need is what is that? 3 and 6. So you can bring 3 here first in this cell, and then you can bring 3 here, and then you can bring 6 from here to here, and then you can bring a next number here or next number here, and just store it somewhere, and you can bring 5 to the final cell, and just you can rearrange it. So now the question arises that how is it possible that we can if after some time there will be some numbers randomly present in this area. Is it possible to bring any of the number to final cell? Is it possible? So let's see an case. Let's see an observation. Suppose this is a part of a matrix, or this is a different matrix. Don't consider about the question. So you need to bring one to the final set. How do you do it? And there is only one empty cell. So the question is, can you do it with one empty cell? Is it possible? So let's see. You bring 3 here, you bring 2 here, you bring 1 here, and then you bring, so yeah, this is the how it looks after this transitions. One comes here. So this becomes the empty cell. You bring 4 here, you bring 5 here. So I think you bring 1 here. Then this is the how it looks. and you okay, so if you after you bring here 1 year in the middle, you bring 2 year and you bring three upwards, so this becomes empty. And yeah, yeah, you can see one can go to this cell and then you can go to final cell. So by this we can see that given in the matrix in a bunch of cells, if there is even if only one empty cell present, it is possible to move one cell, one number to any of the cell, to any other cell, let's say final cell. So we need to have to solve this. We need to we need to check if there exists at least one cell empty. Provide so in the other way, if we want, I want to say, uh, the maximum you can fill other cells is n minus 4. So let's see how that n minus 4 came here. Okay, there is no. Okay, let's see in the notepad. No one. Suppose this is n cross m. Okay, n into m. Let's remove the starting. Uh, let's remove the starting cell. Okay, minus 1. Let's remove the ending cell. Minus the 1. Let's remove. Okay, uh, assume all of them are filled now. Assume after, like, if we can't, because of these two rules, second and third rule, we can't just make the cell, make the number go back here. So we are removing it. And then yeah, let's say all are filled, so n minus 2, n m minus 2 cells are filled. Okay, so is it possible to move at least? No, there's no possible. You can't, all the cells are filled. There is no, you can't move the number from this part, this stack, to any other number because there is no space. Okay, let's say there is only one cell empty. Let's say this is empty. So can we move that? Okay, yeah, we can move it. So yeah, so let's say, yeah, in the sense n minus 3. Uh, okay, let me add here minus 1 here because I'm considering one empty. Uh, one empty, we should keep one empty. I'm assuming it like that. So total n minus 3. So yeah, okay, you can move it, the uppermost it here on this cell. Then what next? There is the empty cells, number of empty cells becomes 0 now, and you can't move this cell to the final cell which you wanted to. So yeah, it's not possible. Let's put another one minus 1. Now let's see. Okay, so initial and final are removed, and this empty, this cell and this cell, the blue circles are considered as empty cells. Yeah, so let's see now. Suppose we brought some number from this stack to this cell. Then what happens? Then we are still left with one empty cell, and we have just proved that we can bring this number to the final by using this one empty cell. So that's the main observation. So how do we do this? Okay, so n minus 4. Okay, sorry. This, and so if the if we can allow at max n into m minus 4 cells to be filled. So let's see the code now. If so, okay, let's see the full code first. Ignore this. This is just an image. Hmm. I took the NMK input array of size k. I'm just using the a map to get the index, like to get the depth of the number in the stack, because okay, I'll tell it afterwards. So yeah, I'm taking the input and I'm just storing the reverse, like I'm storing which number has which index. And currently I'm having this many empty cells. Okay, this green ones are not yet filled. So currently I'm having that many empty cells. Yeah, so current max is one. Yeah. So initially I'm telling that there exists the answer. Okay, is one. And current maximum number of like the maximum, as we are removing, as we are, our aim is to first store k, and then k minus 1, and then k so on till 1. I am checking what is the max depth at till max depth we in which we have reached. So suppose we removed 6 first. Like to remove 6, we removed 3 also. So 3 will be stored in one of the cells here. So If it is removed, then we no need to unnecessarily check here if it is present or not. Uh, to check that we can bring some more elements from here to here. It is not required. So I'm starting with the number initial number k, and I'm checking if I'm checking its depth. So initially the depth I'm assigning is what? -1. So the least one. You can put minus infinity also. So in the let's say let's take this example. So 6 has the depth, like 6 has the index as what? 1. So -1 is smaller than 1. So yeah, then you come to this part, and bonus is the number, like the number of cells which can be made empty, because okay, you fill all the cells here, you fill the, like, you fill the numbers here, but you can free up the space by finding the numbers which are greater than I. Why greater than I? Because if we are processing for the I number, we are sure that the numbers greater than I are already put it in the final block. So those many cells can be filled up. So that's why I have taken bonus in the sense, like those many cells can be emptied. So that's why I subtracted here. So current max is the depth. Okay. So current max is like, okay, the index, zero based index. So zero based, I want the number of elements which are before that, while removing from the stack. So before that, before 6 is 3. So as it is zero based index, 6 index is 1. So there is 1. So no need, it automatically gets into this. So yeah, current max, current I just take the current max as the deepest index, and I'm removing the number of integers which are greater than k minus 1, like greater than I, that is k minus 1. Those many numbers are already filled in there. So I'm checking if these many numbers are to be filled in the empty cells, are do we have those many empty cells? So if the number of empty cells are greater than whatever number of empty cells we require, then it's fine. Else, answer is we don't have an answer and we break, and then we just say that yeah, if okay is true, then yes or no. Yes and no having different languages here. So that's the solution for this. Thank you. Thank you.